All right, now this is being recorded, so I will publish it. Oops, what's... Okay. So, well, let's get back to theoretical part. Lambdas and method references. These are relatively new features of Java language that appeared in Java version 8. And before that, we were able to write everything without lambdas and method references using the so-called anonymous classes. Okay, try to understand this code. What we have here, we have a timer class, timer object, that's going to do something in parallel. We will talk about parallel programming a bit later. This is a library class. So what it does is just delays execution. And we need to tell it what to execute. What we want to execute. And in order to do this, we are passing an instance of object that must implement this interface, action listener. Action performed, action event. So something is a hook is called. This method is going to be called after 1 second. And before Java 8, we wrote code like this. We just instantiated one listener here, and this is called anonymous class. So we are not writing my listener class. My listener extends or implements actions listener and blah blah blah. Action performed, and here we have some implementation. What we are doing here is just anonymous class. This means that we're instantiating it in place. We are using it only once here. We need this implementation only here. And we have this method. And in this method, since it's an inner class, since it's a nested class, the class inside some bigger class, some bigger parent class, the internal state of parent class, of enclosing class, is available for us. This is how it was done before Java 8. Another example. We have some array of strings, and we want to sort it. And let's say we want to sort it not alphabetically, but by the length of a string, by some other aspect, some other property to be used to be sorted. So we are writing our own comparator. It's an interface, so we need to implement this compare method, and we say that we are going to sort it not alphabetically, so we are implementing custom comparator, so it compares according to length of the string. And also what we have here is an anonymous class. So it's a normal thing that it still works in Java, but we use it rarely now because we have lambdas. Another example is an example of predicate. I think you are studying logic already. Who knows what predicate in logic is? What is predicate?
We said Boolean.
Okay, and nobody explained you what predicate is.
Maybe we knew it in the other world.
Okay. Predicate, you can think of, as mathematician, you can think of a predicate as a function that takes objects as its arguments and return Boolean. So the classical, I don't know, Aristotelian predicate, I am mortal, like x is mortal, x. So if you put here me, then it returns true. Yeah. If you put here, I don't know, some God, then you return false. So yeah, predicate is just a function that takes object and returns some true or false about it. So what we have here is an example of predicate. So we want to get a list of hidden files. And see, we have this file filter, which actually is a form of predicate because it accepts file as an argument and returns Boolean value, showing is it hidden or not hidden. If it's hidden, then this list files method is going to return only the array only of those files for which this predicate returns true. So in our case, we are going to get list of only hidden files. It's not assertion. Assertion is something that is going to pass when it's true, when some condition inside it, right, is true, and is going to throw exception if condition inside it is false. So assertion assert takes boolean here, and predicate takes object here. It's
Vice versa.
yeah, it's something, yeah. So you think of a predicate as a function from some objects to true or false. All right, and welcome lambda expressions. Starting from Java 8, and you can see that these things are lengthy, are wordy. So this is many people criticized Java for that. So to write some simple thing, you need to write lots of code. So starting from Java version 8, in lambda expressions in language appeared. So Java was language where many concepts appeared first, but not lambdas. Lambdas appeared earlier in other languages, and this is how it looks like now. So instead of passing this anonymous class here, creating this anonymous class like this action listener, we are overriding this method. We just writing it like this. A single line lambda expression that takes two arguments here, string first, string second, and it returns integer. So lambda is actually a function, and the function has arguments and has return value. So here we have lambda that takes two strings and returns integer. And this lambda can act as comparable interface, as comparator interface. The second example, we can write lambda expression just a single liner. Here it just returns an expression. We can use multi-line. Then we're using curly braces here, and we can write any code, any ifs, any loops, anything, just anything you want. And then it will look like method implementation. So you need to call return to return some value. Unlike lambdas in other languages like Kotlin or Groovy, if we have curly braces here, we need to use return. And even more, we are not obliged to pass some arguments. This is example of no argument lambda. And we are not obliged to return something because println returns void. So this is also an example of lambda expression. So yes, if we are using multi-line lambda, or if we are using curly braces, then we must use return. If it's a single liner, then no curly braces, just for the sake of clarity and shortness of code. Okay, which of these are valid lambda expressions? Now that you know. How about this one? Does it look like a valid lambda expression? Why?
Because it's empty.
Because it's empty. Yeah, it's empty lambda expression which accepts nothing and returns nothing.
But so it can be.
It can be. Still it can be. This one is very unusual looking, but perfectly valid lambda expressions, and sometimes you will utilize this exact code in your code when you have some API and this API demands some lambda to be passed and some runnable to be passed.
It's like shortcut.
Yeah, so you can just do nothing, and we have curly braces here, but since it doesn't return anything, we don't need return statement here. Okay, how about this one, the second one? Is it valid? Is it a single line expression?
Yes.
So why isn't it valid? It's valid. It's constant expression, yes. When I told you that lambda is just code that does something, it's not necessarily for the code to do complex stuff. See, so here it just returns constant. So this is perfect example of lambda. It's just trivial, but it just always returns constant. Okay, if the third one is valid. Yeah, it's multi-line. Oh, it's not multi-line actually, but it's we're using curly braces, so we're having return and this semicolon. If you write this lambda in IntelliJ IDEA, it will propose you to change it to something more concise. But still, from the point of view of Java compiler, it's valid lambda. Okay, what about the fourth one? Is it valid or not?
You can't return like that.
Why?
But we didn't initialize
I is a parameter here.
Yeah, but okay.
I is a parameter here. We can concatenate string and integer, so integer will become converted to string, so no problem so far. And why is so is it valid or not?
Look like yes.
But actually not, because we are using return, and since we are using return, we must use curly braces. So and the semicolon. Yeah. And this one?
I think it should have return because
Yeah. It should use return and
or
semicolon.
without curly braces.
Or without curly braces. Yeah, you got this. So yeah, I think now it's absolutely clear for you what correct valid lambda expression in Java languages. It's simple. Sorry? Third one. Third one is valid because we're using curly braces and return. As I told you, if you write this in IntelliJ IDEA, it will compile, it will run, but IntelliJ IDEA will ask to change it to something more concise, because we can just replace it with Mario like in the second one, and it will do the same, but will be more concise. But still, from the point of view of Java compiler, this one is valid.
Why is the semicolon inside the
Because we are using semicolons after lines in Java. So this is actually an example of multi-line expression in Java language. We can pull before this return there might be some complex logic, and we just use semicolons. Okay, so what can lambdas be assigned to? So these are lambda expressions. And each expression, like 2 plus 2, has a value, and this value can be assigned to some variable, like integer variable, like int I equals 2 plus 2. And here we have lambda expressions. So lambda expression is not the result of this expression. It's another sort of indirect call. So what can lambdas be assigned to? So here comes the thing called functional interface. A functional interface, the interface in Java language is called functional interface if it has no more than one abstract method. If you have an interface, and in this interface you have exactly one and only one abstract method, then this interface can be called functional. As I told you earlier, in interfaces there might be default methods, not abstract methods. So you might have multiple default methods, but only one abstract method for the interface to call it a functional. And if we have such an interface, then it's clear what to run, what method to run if we are going to run a lambda assigned to an interface. So we can also tag this interface with functional interface annotation. But this is not obligatory. This is not obligatory because of backwards compatibility, of course. There were many interfaces that were functional before Java 8, and Not all of them can be marked functional interface, but it will help you to write code, because if you mark an interface with functional interface annotation, and then when you try to put more than one abstract method to this interface, it won't compile. It's just a check for compiler. And in order to assign lambda expression to a functional interface, the interface method must match the parameters and the return value of lambda. Like in this example, action listener is something like e to something, like it doesn't return anything, so it might be void. So action listener is assignable to this sort of lambdas. Comparator string. Here we have a comparator string has one method called compare, and it accepts two string arguments, and it expects an integer result. So here we have a lambda expression that's compatible with this type, so this assignment will compile and work. And please note that we are not specifying the types of lambda arguments here. So we might put string s1, string s2 here, but as well we can omit these types. This doesn't mean that these variables are not typed or untyped like in JavaScript language. They are still typed, and their type is string, but this type is inferred from the left side of this assignment. Like if we have comparator string, then what does compiler do? It says, which is the one and only abstract method of comparator? Okay, this one. This one, which values does it expect? Two strings. Okay, we have two values here. If it were 3 or only 1, then it fails to compile. Now we have two parameters, and 2 parameters in that method. Okay, which types? Strings. Then the compiler will assume string type for S1 and string type for S2. And also it will check for return type. Return type must be integer, and here it is. Here we have integer result. So this is an example of assignment from lambda expression to some variable typed as functional interface. And also we can see type inference of Java. So we are not obliged to put types here, and this is very important. Some people just praise this feature when it appeared in Java 8, because now we can write more concise code. But as you can see here, looking only at the code, now it's very difficult to understand the types of these variables without the help of IDE. But this is what modern programming is. If, I don't know, in 1990s it was very important for you to read just plain text in plain text editor and understand all the code. Now when you are coding in modern programming language, you just cannot understand the code without help of IDE. So this is what type inference in modern programming languages are. Maybe it would be more clear if we were obliged to put string s1, string s2 here, but we are not obliged. Also we can. Okay, void compatibility. If lambda, if a functional interface method expects void result, in order to assign, lambdas are assignable that return void or non-void. So if we can just ignore the result, because for example, list.add, it returns boolean, and thus it's assignable to predicate, right? So it's quite an unusual thing to see that list.add, it returns boolean, and thus it's not only says something about s, but it's also mutates some external state. So this is an unusual, maybe some unusual example of lambda, but still it's a valid one. But also we can use this as consumer because consumer.accept, it returns void. So it doesn't expect of list.addS to return anything. But still, this lambda is assignable to this interface because we just throw away the result of list.add and it works perfectly well. So this lambda can serve as consumer, and in most scenarios it will be should be considered as a consumer. Okay, another thing that we must understand, that before this lesson we assumed that object is a universal super class, super type, and you can assign just anything to object. So anything, I was telling you, anything in Java is object, with the exception of primitive types. Like you cannot assign 5 to object, but Java will auto box it for you, and it will convert 5 as a primitive to integer with big I object, and you can assign it to an object. It's not more valid with lambdas because object is not a functional interface, so you cannot assign just this will not compile because it's an empty lambda. So you say, it might be an object, but this assignment won't work because this assignment works only if there is a functional interface on the left, so that compiler will know which method to run. Which method to run on object if we want to invoke this lambda. Just no idea, because and this will not compile. But if we assign it to runnable variable, like this one, runnable R, then it's okay, because runnable has run method that accepts no parameters, and it doesn't expect this to return anything. So this will compile, and after this, or after just casting this to runnable, we can assign this to object. Also, it doesn't make sense because when it's object, we completely lost all the information about the type of this runnable, that it's runnable, that we can run anything, or something like this. Okay, and intermediate conclusions. See the difference between Java 7 version code and Java 8 version code. On the left is using anonymous class before invention of lambdas, and to the right we have code that we can use after invention of lambdas. So it's much more concise, much more clear, of course. It's much more readable. So instead of all these wordy things, we can use lambdas, and okay, fortunately we have them in Java language. Just don't be afraid of them, just utilize them. And actually this is not everything about lambdas. In lambda, just like in inner class, we can have access to some outer variables, some outer scope. So if we have like this method, like we accepting string text, repeat message, like and with some delay, and we are going to repeat some text with some delay. So inside this lambda, we can use this text variable. Although text is not a parameter of lambda. Text is a parameter of repeat message outer method. But in this lambda, text is just like in the scope of this method, just like inside the scope of this method. And so it's easy to write, but we also need to understand how it works. Because when we pass lambda to this listener, to this timer here, we are exiting this method immediately. Like we just created a new timer, we just passed this delay, and we just started the timer, and then now we're exiting this method, so we are losing any reference to this text variable. And so actually, when we passed this listener variable here, a listener not only contained this the reference to this snippet of code. It also contained all the closures, all the captured variables that are needed for this lambda to be executed. Thus, it just took this text, memorized it, so inside some invisible field under the hood, and this text can be used. And this implies some restrictions of variables that can be used in lambdas. These variables must be effectively final only in Java lambdas. This means if we have integer start, some integer start variable here, and we are going to, I don't know, create many action listeners inside this for loop here, and in this action listeners we are going to mutate this start variable, and this won't compile. Why? Because what Java expects from us is that actually what it captures, what it the captured values that are captured inside mouse are actually constant values, so they won't ever change since they are assigned before the invocation of method that accepts lambda. So this will end up with error can't mutate captured value, and this will end up with compilation error. You cannot refer to changing I because here I is changing. So effectively final variables are those that are either already final, so you are just defining final variable, you are assigning some value to it, and then you are not going to change it afterwards. Or if you put final for them, the code will still compile. This means after some point on this, when you assign this variable, you are not going to change it afterwards. Compiler is able to define the effectively final so that it doesn't force us to write extra code. So it's good for you if you put final variable, if you declare a variable as a final, then it will be more clear for you maybe, but you're not obliged. Is another implicit thing, another implicit modern feature of language. So it just implies that this variable is effectively final, but you must understand that it's obligatory for you to use only final or effectively final variables. Well, I have to say that this is not the case in Kotlin. For example, in Kotlin you can utilize mutable variables inside lambdas, but it was made at the cost of extra memory overhead and extra performance overhead. In Java they decided to utilize only immutable variables inside lambdas. Okay, and this is not the end. This is not all. We can do even shorter than this. Instead of writing this lambda like event system out println event, we can write it like this. Because many times the lambdas that we are writing are just a delegation to a method call of some class. So it's a very common scenario when the lambda that we want is consisting only from one method call. So instead of lambda expression, we can utilize method reference. So method reference is another form of lambda expression, which means please call this method with such and such parameters. And here are some examples of method references in Java. Instead of writing this, we're telling, okay, please call println method on the object system.out. So this is where method reference begins here. Like to the left of this expression, we are just figuring out which object do we need. Like here, system.out is object, and then we are using this colon syntax, and we say please call println. What does this mean? Println accepts, for example, one string parameter, and it returns void. And to the left, or here we have lambda that accepts one string parameters and returns void. So these are actually equivalent, two equivalent forms of writing the same thing. This one, two strings, and we want to compare them ignoring case. Here we have a reference, method reference, but slightly different one. Instead of object here, we have class reference here, string, and see what we have. We have S1 compared to ignore case is a method on class string. So first one is the object itself. The second one is a parameter of this method. But as a result, we are getting a lambda that that needs two parameters. See? S1, S2. S1 is an object itself. S2 is the only parameter of compared to ignore case. And thus we can write it like this. String, double colon, compared to ignore case. So for this to execute, we don't have some concrete object here, like in this scenario. Here we have only class. And but still we need an extra parameter in the very beginning, like this S1. Does it make sense for you? Okay, so yeah, this is important. This is a tricky stuff.
The question is like how does this string colon convert to ignore case? How I understand how the parameters actually pass there.
Yeah.
How is this used?
How it's used? If you are writing like writing it like this, it's converted to lambda, and this compared to ignore case is not a static method. We are going to cover static methods later. It's not a static method, so it needs to be called on some object. So the first parameter is the object, and the second parameter, and third and fourth are going to be parameters of this.
So they're called like on like dot, string, and
It's it's going to be converted to exactly the same lambda. I will reiterate this on the next slide. And here is another example. Math.power is example of static method, so it doesn't need any object context to be run. So this is easily converted to method reference. Math double colon power is just like this lambda here, because it accepts two arguments. So what we have here is three ways to define method reference. So this is just just a picture that explains the three types of method references in Java. So when you see double colon in Java, you must understand, you must define for yourself what actually does this mean, because it might mean three different things. I just warn you, because for many novice programmers they just capture this one, maybe this one, but not this one, and they just going crazy. They just cannot understand this method reference. There are three ways to define method references. If we have object, we can call on object double colon method, and this will mean the following: like all the parameters of methods will be parameter of lambda, and the object we already have here, like you see. Here we don't have object, it's instance method, so it will be converted to method to lambda, and the first parameter of this lambda will be an object on which instance method is called. I think now you see, right? And the third one, it's a simple one, most simple one. It's class static method. Static method is just plain function. It just can work without any object, so it works like this. So we have parameters of static method, and they just convert it to it. Okay, so these are three methods, three ways to define method reference. And besides that, we have constructor and array constructor and array constructor reference. I think this makes sense for you. We can write class new, and constructor is a sort of static method, in the class, right? Because you're just calling constructor with its arguments, and so it's going to work. And this one is tricky, and it's very rarely used, but still it's there in Java language. You can call array constructor reference. So it works like this. First argument is going to be integer, of course. It's going to be size of array that you want. So this is just lambda that accepts integer as its first argument. So you will get an array of class with a given length. Okay, and talking about lambdas and method references, one might ask, are they always equivalent? Because in many scenarios you can change lambda to method reference, and in many scenarios you can change method reference to lambda. In most scenarios you will change lambda to method reference, because as you can see, as you can plainly see, method references are just more concise. They are just more concise, and they are more performant in Java under hood. So usually there is no reason to use lambdas when you can use method references, right, instead of lambda. But there is a slight difference about invocation, or about I don't know, calculation of these lambdas and method references. Like see, if we have object that might be null at certain point, and we are calling some method here in form of lambda, and this object might be null when we do something, then null pointer exception will be called on lambda invocation only. When we invoke lambda, a Java virtual machine will find that object is null, and NPE will be thrown. If we are calling this one object double colon method as invocation, as method reference on our object, then null pointer exception will be thrown when we're calling do something. Not when do something will call internally, will call this lambda, but when we are calling do something, because in order to calculate method reference, Java virtual machine must dereference object, and if it's null pointer exception will be thrown earlier, which is actually better, because remember, throw early, catch late. The earlier we get an exception, the better, the easier it is to debug. This is maybe another argument why method references are superior to lambdas, and if you can use method reference, please use method reference instead of lambda. All right, what else do we have? We have methods specially created in standard library to be utilized as method references. Like this, we have class objects, it's utility class, and it has some methods that might look stupid for you, like this one, objects dot is null object of object, and it returns true if object is null and false if it's not null, and vice versa, objects dot not null. So come on, you might think, come on, is it hard to check it using simple if? Why do they put this stupid thing inside the standard library? They put it inside standard library on purpose, and this purpose is to use these methods as method references. Like this, list is just list, and list interface has remove if method, and remove if method accepts predicate here, and this is actually predicate, so we can remove all the null elements from list using this single liner. Just concise and beautiful code here. And like stream filter objects non null. So here we are just using these methods. We are not calling it in ordinary code like inside your methods, but you can pass these methods as method references. Okay, and as I told you, in order to in order to write your lambdas, you can assign them, and if you want to write some method or some library that works with lambdas, you must think about functional types. Like you're writing a method, and this method is going to accept some lambda, so you must think about the functional type of the parameter of this method. Like, what do you want from this lambda? What parameters do you want from this lambda? What's return type? And in practice, you usually never write your own functional types. So you might think from the beginning about when I told you about this functional interface annotation that you must just define your own interface and put the functional. That's what novice programmers often do, but I warn you against this. Please don't define your functional interfaces when you can reuse the standard ones. And in most of the cases, in 99% of the cases, you will perfectly do with standard functional interfaces already defined in standard library. And these ones are most commonly used. First of all is runnable. Runnable is used in libraries which are suited for concurrent programming, like please do something in parallel. Yes, I assign you some task, please do it in parallel. And you are just passing runnable to it. So it doesn't accept any arguments, it doesn't return anything, it just does something. Supplier. Supplier is a function that doesn't have any parameters, but it returns something. And due to generics, hopefully you all know what generics are from our previous class. By using generics, this is a really generic interface, so it can be supplier of anything, of strings, of integers, of your, I don't know how complicated your stuff, but you just can pass it as a type parameter. Here it will work as supplier. Consumer is vice versa, something that just swallows something and produces nothing. And B consumer is a consumer that can swallow pair of things. Okay. Using these functional types, we can also do some functional programming, like combining lambdas into another lambda. When I told you about lambda expressions and that method references are just expressions, what can we usually do with expressions? If expressions are numerical, then we can add, divide, multiply, and do stuff with numerical. If expressions are strings, then we can concatenate strings and take substrings out of strings. So usually we can do stuff with expressions. And the most wonderful thing about lambda expressions that you can also do stuff with lambda expressions. They are actions and you do stuff with them. Like this. Like and then here you can just I don't know have some consumer, and you just can write another consumer that will work as a consumer for strings, and it's compound out of this one. When we write foo and then list add, this one is a functional expression on two functions, like see, foo here is function. Oh, it's functional interface. Foo dot and then is operation of this function. And what we have here is functional expression. So what actually consumer string bar doing? It does the following. First, it calls consume method on foo, and foo consumer will consume this string. And then this string will be added to some list. So instead of writing code in the way that you are accustomed to, writing first do this, semicolon, do this, semicolon, do this, semicolon, now we are writing code in functional way. That's what functional programming is about. This is another paradigm. And Java is not functional programming language. But you must understand, you must know at least at this point that not all the languages share the same paradigm. Most modern languages, they are multi-paradigm languages. This means in Java, mostly you are writing object-oriented code with in traditional procedural style. But if you wish, if you are willing to do some functional programming, then you can do using standard library and combination of functional interfaces. There are languages like Haskell, which are just built around functional paradigm. So you are writing code not in this style. Do this semicolon, do that semicolon. You are thinking about functions and composition of functions. So my goal here is not to teach you functional programming. I just show you some trivial examples, but you must from now on understand that there is such a thing as functional programming. It's quite a big thing, and you may study it as well. Okay, another examples of functional interface. First of all, the most commonly used functional interface is function, of course. Function is functional interface, and this is most commonly used because I think it makes sense for you why function has two type arguments here, t and r. T is the type of argument of the function, and r is the type of result of the function, right? So if you have something like foo of t of something of my var, and this foo returns result r, this can be converted to functional interface called function, because it's a function, a single argument and single return value here. So function tr is the most commonly used functional interface in Java language. B function is a function that that expects two arguments. If you want a function with 3 arguments, then you will certainly need to define your own functional interface, not library one, but this is a rare case. In most cases, you 1 or 2 arguments will do for you. And here are examples of compositions and of functions. This is the most the most tricky or the most common use thing. If we have, say, function f, and we might apply it the following way. Like, first we want to calculate g of x, and using this result and use it as argument of function f. What we got here is another function, like composition of functions. In mathematics we also write like this. So we're using 2 functions to compose a single function out of 2. This composition resembles like multiplying of numbers. So actually in mathematics the composition of functions is just an operation like multiplication. So if they are compatible argument wise, I think if return type of function g can be argument of type f, then you can use this compose method. So these are examples of composition of functions. Okay, there are also operators, and operators are like, I don't know, if we have a plus b, b here works as operator, and the result is of the same type as a and b. If a and b are integers, then result of plus is also integer. So this is why it's called binary operator, and it's only one type here, because it can be b function with t and t and t, but instead of b function we can use binary operator. If you are studying algebra, formal algebra, for example, Are you studying formal algebra?
What do you repeat?
Groups, semi-groups, monoids,
No.
things like this. Oh, unfortunately not. Okay, but this is from this area. So binary operator, unary operator, they are from formal algebra. Okay, and predicates. Predicates, as I told you in the very beginning, are just functions that takes some parameter, any parameter, and return Boolean. I think now it's clear for you. Okay, predicates can also be composed, and with predicates you can compose predicate with your familiar functions like and or negate is equal, like x is mortal x and human x. See, you can, or just or human x. It just will be different predicate. You understand how it works. Like, so, yeah, I shown you example that lambda expressions and method references can be combined. You can do stuff with them, and you can also combine them. Work just with like with any expression. This is we also have functional interfaces for primitive types. There are lots of them because of the limitation that I explained to you on the previous class. In Java, we cannot utilize primitive types as parameters as type parameters. So I just, unfortunately, I cannot write predicate of int here. This must be integer. But in order to save resources, I can utilize int predicate from the standard library. So it's actually not p supplier, p consumer. It might be int supplier, long supplier, or double supplier. And also int predicate. It's just been made for because of the restrictions of generics. And hopefully in future versions of Java will get rid of them. We'll be able to use predicate of int. All right. This is it about lambdas and method references. How can we utilize them? In Java 8, there appeared lots of very convenient default map interface methods that we can utilize, and I strongly advise you to utilize them. And you can use lambdas and method references for them, like this. Compute if absent. So usually when you, I don't know if we have an example of code, or should I write this code here? We have some time, so maybe I should just hope you see some code, just a random working project. Let's spoil some project. Okay, usually if you have some, let it be, if you have some I don't know, hash map hash map of string dictionary like this, and like, oh come on, if you have this dictionary and often you write things like this. You have a value that you might I don't know, get from this dictionary, like dict get foo, and you often write the code like this. Some let it be like key, and if you getting this key, you often write it if dict dot key is null, equals null if map doesn't contain this value. You're writing it like okay, let's put key, and as a value maybe some value that's calculated based on the key. Say, I don't know, say prefix plus key, and then return. Let me extract it to a method. So let it be extracted. Like, okay. So no, I don't want hash map to be parameter of this method. I want key to be parameter of this method. So let me just okay, extracted for, and it's going to be string key. Now it's compiled. So but it's not void. I'm going to return some value here. So I'm just going to print it to console. So now it doesn't compile because we need to return some value. So I say let's return some value like this one. Return. I can put it this way: dict.get .key, and of course return. Yeah, this is not Groovy. This is Java, so we need to put return here. Okay, I think this code makes sense for you. We are asking for some key in the dictionary. We didn't find it, so get returns null. So we are calculating the value, and we are returning this value, right? So actually this dictionary can be some shared, but it's a static method, so let it be like this one. But actually it doesn't make sense, so sorry, I will change it. It's not going to be a static method, so let it be new, what's this class called? New vehicle. Okay, then let it be new vehicle constructed. Now it makes more sense. Like here in constructor, for example, we might add something to this dictionary at least. So this is how it often works like, but you can do this simpler, and I strongly advise you to use this stuff. You can use compute if absent method. What does this mean? We can return dict compute if absent. If and the first parameter is of course key, and the second parameter is a lambda, which will be invoked if key is not there. If key is there, then we will just return the value. If key is not there, then we can utilize lambda. And let's write this lambda. You see its function question mark superstring question mark extend string. Why it is so, I will get back to it sometime later. But now we should write a function here. So let it be mapping function. So parameter is key, just key, and the value is prefix plus key, right? So now it's compiled, and now we made code shorter. Good. Can we do better? Yes, we can, because what do we have here? Plus key. What do we have here? We have here just lambda, but we can do method reference. Concat is actually a method that does concatenation. And actually, lots of code just changed to one-liner here. So this is very powerful. This is a very powerful default method. This is a very powerful things that you must use everywhere in your code. So maybe in your game of life, you might think about just changing something like extra ifs, extra things when you are just looking up something in your maps with lambda expressions. And what's good about this computive absent? You know what's good? That this one is going to be thread safe. When in 2 weeks I will tell you about concurrent programming in Java. This is a very hard topic, so be prepared. It's a very tricky topic about concurrent execution. And I will tell you that it's very difficult to write the so-called thread-safe code, the code that will execute correctly from different processes, from different parallelly running threads. And this one, since it comes from standard library, it's already thread-safe. So you can consider this as atomic operation. So you're just passing a lambda here. It can be this simple method reference or some complex lambda. It depends on your task that you solve. But if we are going to call this extracted from different threads in parallel, still you will not end up with calling this method twice, only once. If it's not there for the first thread, for some first thread, then it will be called once, it will be computed once, it will be saved inside this dictionary, and then the cached value will be used. So this is actually a very powerful thing that we wrote. You can write it in a not thread-safe way using simple ifs. If it's null, then calculate new value and put it here. Imagine that somebody already calculated and put the new value in the period when you read this null and calculated your value. See, that's called data race. So this one will not cause data race here. So this is another argument why you should use this computive if absent instead of just plain checking for ifs and calculating and so on. So these are quite powerful stuff. Okay, let me switch to slides. I showed you only computive absent thing, so there is also computive present, just compute merge, and so on. You can read about them on documentation. So this is really powerful stuff, and you must know about it and you must utilize it in your code. No, please don't use this if blah blah dot get equals no, then so. Comparators is another powerful functional oriented stuff in Java, and this is actually quite often used in enterprise application. For example, a list of persons. A person has a first name and has last name, and we want a list of these persons sorted. And how do we usually sort them in enterprise application? We sort them according to last name. If last name is the same, then we are sorting them according to first name. So you can do it like this. For example, if we are going to sort them according to last name only, we can use lambda expression for this stuff. So we can use anonymous class, but I'm not showing you anonymous class. As you might imagine, there will be lots of code for anonymous class. New comparator and blah blah and so on. You can use lambda here. P1, P2, P1 get last name compare to P2 get last name. And this is a correct lambda. And this lambda itself cannot be converted to method reference. Just because we have a method call here, then method call here, and it's too complicated, and we cannot convert this one to method reference. So this lambda cannot be converted. But we have a utility method called comparing on comparator class, utility class. This comparing thing expects some lambda expressions inside. And it says, okay, just give me the method of extracting the thing that you are going to compare in your class. So this is that simple. person get last name. It's just getter for the last name of person, and it will just and you will have a comparator here. So you just use collection. So this is very simple example, but more than that. Imagine you might want to sort by last name and then by first name. Oh, not everything is translated. Fix it. Okay. Before Java 8, you must have written this code, lots of code. Okay, let's try to understand. First, we are comparing it get first name compared to get first name. Oh, it's actually first name then last name. Doesn't matter. One of the properties. If it's not is equals to 0, this means that people have the same first name. Then we are going to compare using the second field, the second getter, right? And then return result. If it's not 0, if I don't know, these names are different, then we are using this result of this comparison. If it's 0, this is called lexicographical order. When we, how do we? Let me just come back to my mathematical classes, because I used to teach people set theory also. So imagine we have just one axis, one dimension of numbers, and it's understandable which one is bigger, because it's to the right, it's to the left. And if we have two dimensions, how do we compare this dot and this dot on the plane? Comparing, I mean that it will persist all the properties of comparison. So we can do the following. We can just put this projection here, and if this projection of this dot is to the right, then this dot is bigger than this one, because we're comparing the first axis only, the first component. But if we have a situation like this, when these two components are the same, then we just comparing the second components, the fallback. So this is what, and of course this can be expanded to any number of dimensions, this lexicographical order. And this is why it's called lexicographical. It's like what we have in dictionaries. If we have like AAB, AAC, we know that this word is is going to be earlier in dictionary than this one, because we are comparing first letter, they are the same, second letter, they are the same, we compare the third letter. So we all know how in dictionaries, in encyclopedias, words are ordered. So this is called lexicographical order. And this is how we must be doing before Java 8. And of course this is lots of code, and of course it's easy to make mistakes. Please don't do this. Don't write this horrible mess yourself, because what you must do is to utilize standard library. This is the correct way to do it. Please see. Comparing person get last name, then comparing person get first name. By the way, I just realized for the third or fourth year of showing this slide that this code actually contains a mistake, because I'm going to compare first name first and last name last. This is buggy code. And this is another example why you should not write this. It's very easy to put bug here. Here you will never put bug, because it's just like you declare the result that you want. In functional programming, see the difference. Here you just explain what to do. Do this, then do this, then do this. Here you just declare the needed result. I want to compare first by last name, then by first name. And here we go, much concise code, and it will do just exactly what we want. This is what functional programming about. You might heard before that there are declarative and imperative way to program. Declarative languages and imperative languages. So what you wrote before was imperative style, when you just explain step by step what to do. And this is an example of declarative style programming, when you just ask a computer to do something for you. This is tightly related to our next topic about strings, but I think we won't have time for it now. So also we have comparator comparing by key extractor. Also we have comparator reversed, like the order might be reversed, so you just put dot reversed here. So I just want to sort it in reversed order. Just put reversed here, and it's like clicking in Excel. You know that there's A to Z, Z to A. So you just add reversed here, and you get what you want. So it's that easy. Okay, I will not show you this one. Okay, I will show you this one. It's, I don't know if you see it. Let me just get it bigger, maybe, so that you understand what's it about. So this elderly man is coming to doctor, and it says that his code won't compile. And why it's not compiling? This is a sort of extra difficult question maybe for you at this point. This is why this slide is in the very end, and I was not going to show it to you, but you saw it. Why it's not compiling? It's not compiling because we have a chain of method calls here, and the Java compiler is not able to infer the actual type of P here, because when we call comparing and when we call reversed here, then Java understands that reversed can be called on any comparator, not just comparator with some specific type of P. And here, when we have calling comparing, P for Java compiler, P is just an object. So we can either put this here, this patch here to our code, just telling Java compiler the way that actually this comparing method is a generic method with this type arguments. Another solution might be better solution. Is that we're calling round braces and call file P to P get file name and so on, so on. This will compile. So, and you see that the elderly man is, now it's okay for him, although he's just a painful solution, but okay. This is about Java. It's all about Java, that it's not everything is perfect in Java language, and this is because of many restrictions. And I told with Tagir Valeev about this one, for example, and many Java languages designers, this is well-known problem in Java language, and they just cannot do anything about it because it would break many things. It would break many tools. It would break backwards compatibility. So leave this and just understand that sometimes type inference in Java just doesn't work as you want it to work.